Hello everyone. Today we are going to solve the problem array duplicates. So it is one of the question from the top array problems. So the question is given an array ARR of size n. So containing elements from 1 to n, where n is the size of array. So and each element appears at most twice. So return an array of all the integers that appears twice or duplicates. So note, we can return the elements in any order, but the driver code will print them in the sorted order. So it is their task. We just need to return the list of or the array of elements which are duplicates or appears twice. So if you see in the first example, the array is ARR and the values are 2, 3, 1, 2, 3. So except 1, if you see, the 2 is repeated 2 times, although they said at most 2, and 3 also repeated 2 times. So 2 and 3 are duplicates. So the output is 2 and 3. So they appear more than one time. So in the second example, we can see 1, 2, 3 or 3, 1, 2, the actual order. So all the three elements are only appearing one time, or all the elements are unique. So the output will be empty. So there will be no duplicate elements as the output. So if you see the expected complexities, there is big O of n time complexity. So we can use a for loop or any loops one time without nested ones. And the auxiliary space is big O of 1. This is where our type of logic differ. So if it was the big O of n time complexity, space complexity, so we can use a set, or we can use a most used one like the frequency map. So we use a map to count the frequency of each number, and we add the result to the numbers such that if any number whose frequency is greater than 1, so it is obviously duplicate. So we add them to the output list. So it is the most basic one using the frequency map or a hash map. So they all takes big of n time n space. All the time is big of n, but they also take space as big of n. But we need to solve this program in big of 1 logic. So you can say it is asked in many companies: Zoho, Flipkart, Amazon, Paytm, Qualcomm, and etc. So it is a most frequent question. So how can we solve this? So based on these given conditions, like every element appears only twice, max means, so if a number appears once, not duplicate, twice it is duplicate, and the elements are from 1 to n range. N is the size of array. So based on this given constraints or the given conditions, we can use a technique called index marking or index mapping, anything. So normally for index marking, we use a separate array of the same size of the given array, and we will mark them as found or not found based on their index by changing the default value to -1 or something. But they said, as you can see, the big of 1 space. So we need to use the given array only as a index marking. So how can we done this? So things used will be a for loop, if condition, and a variable. Three things we are going to use. So steps. So we said we will use index marking. So in this we will do if for any element n, we index like the given element absolute value of n minus 1. This is going to be the index, any index, like this is our own logic we are going to implement. So at this index, as we can see, they said the minimum number possible will be the 1, as the range is from 1 to n. So at this index, if the present is negative, then what does it mean? The is already found, so duplicate element. So that's it. So we can see the whole text. So we can see what is the index marking technique. So if the number present is negative, the value is already found. So it is duplicate element. So what should we do if it is a duplicate element? Simply add to the output list. So but if the element, if you see, but if the number at the computed index number present is positive, then we know that it is a unique element, means it is found by the first time, not a duplicated time. So if it is positive, then make the element negative. That's it. This is the index marking technique we are going to use. So steps. So if we see with an example this logic, so if you take the array, the first one, given one, so the array will be 2, 3, 1, 2, 3. That's it. 2, 3, 1, 2, 3, 2, 3, 1, 2, 3. Okay. So as we are iterating the array, the first element will be 2. So for 2, we compute index. So I is equals to, what is the index? The absolute value of 2 is 2 minus 1. So the I is equals to 1. So what does it mean? We said that we will check the element at the computer index. So I is equals to 1, the element is 3. So 3 is greater than 0. So it is positive. Then in that case, we said we will change that value at that index to negative value. So the modified array will be 2, minus 3, 1, 2, 3. That's it. So the same array, the same value, but the sign of the computer index value will be just changed. So if you come to the second value, then it is minus 3. So for minus 3, again we compute the index. So I is equals to absolute value of the present value. So absolute value is 3. 3 minus 1, it is 2. So 2. The value at index 2 is 1. It is again greater than 0. So simply make that value negative. So 2, minus 3, minus 1, 2, 3. And next, same for the minus 1 value. We compute index I is equals to, it is already minus 1. So absolute value is 1. So 1 minus 1, it is 0. So again, I is equals to 0. 1 minus 1 is equals to 0. So 0 is greater than 0 means, let us say greater than or equal to 0. Actually we are going to use the opposite condition, which is less than 0 means only the other thing we are going to do. Just for the writing purpose I am writing like this. So again the greater than condition is met, so update the value. So -2 comma -3 comma -1 comma 2 comma 3. That's it. Now it is going to make the difference. So we completed the 0th value, 0th index, first index, second index, now the third index, so which is 2. So for 2, if you compute the index, 2 minus 1, it is 1. So for 1, we can see the value at index 1 is what? It is -3. As you can see in the updated array, we are writing continuously. So the value is already less than 0. Means we didn't update this time. Before updating only we are checking. So if it is already less than 0, then that means the current value in that iteration is a duplicate value. That's it. So no changes to the array this time, but the output is empty because the true case was met here. It is also empty, but in this case, as you can see, the less than condition is met. So in this case, greater than condition, so array is modified, output is not disturbed. Same for this, array is modified, output not disturbed. Array is modified, output not disturbed. Here the less than case, array is not modified, but the output, into the output, the current value of that iteration, which is 2. So the value 2 is added like this. So actually we are going to add the index plus 1, which also again gives the same value. So okay, so now output is -2. So again, what is the last element? It is 3. So compute same. What is the computer index of our own formula? It is the current value 3 minus 1. So it is 2. So we check the value at index 2 is what? It is -1. So -1 is again less than 0. So no changes. No changes to the array, the modified array, but add the current value to the output list. So at last, output is equals to 2 comma 3. So if we see the output here, it is 2 comma 3. So this is how our index marking logic will be working in this dry run. This is called the dry run. Before writing, we work out our logic if it works or not. So we can see our logic is working. So we use the same logic, the index marking technique, in the self, the itself marking, using the same array only, but it is usable in some constrained cases. Like here we can see the range will be 1 to n of the array size n, and also the duplicate element is not appeared more than 2 times, exactly 2 times only at most. So at these constraints our logic is working. So if you see, we said first we need to declare the return type of the function. So it is collection name array list, and collection type name can be result res, and memory allocation is new keyword, and again the collection name, and we use a for loop. So in for loop we can use a for each loop or a normal index based for loop. So but for simplicity we can just use a for each loop. So for int n, enter n means num, so num from the array. So the first step we are going to do in the for loop for each iteration is find the custom index. So how can we find the index? It is absolute value, means only the positive value of the number minus 1. So as we write here, we check two conditions. So one is if the value present at the custom index is if less than 0 by default. If it is less than 0, that means the current value was a duplicate value. So we just add the duplicate value to the result. The duplicate value, absolute value, only the positive value is, simply we can write the index plus 1, because current value we subtracted minus 1. So again we need to get current value means plus 1. Simple. You can also write mat.abs of num. It is simpler, but so else if the current value is not a duplicate value, but it is a first time found unique value, then we said we update. So for the indexing mechanism, it is better to use the for loop, normal one. I less than. How can we iterate the for loop? This is the logic, simple for loop. Using the indexing of an array, I is equals to 0, the beginning index, and I less than AR dot length. The length is a variable from the array object, and every time increment the array. So it is not num, array of I. So if array of I, we can't use both names same, so keep it as j. So if array of j is less than 0, then array of j is equals to minus of array of j. So we're just negating the value. Two, 3, 1, 2, 3. The output is 3, 4, 8. So there is a mistake. If you see, sorry, here it is j. I was the index. So now if you modify here, so this is how we are going to debug error if it comes. So due to the multiple indexes I and j, there is a bit of confusion. So I think we can just use a for each loop, but okay, as far of now it is okay. So sample test case is passed. If you see the hidden test cases, they are also passed. So now if we observe our logics or codes complexities, the space which we created here is related to the output which they have given here. So the extra space which we are declaring specifically for the return type or the return value only of the function. So we can exclude that from the calculation of the auxiliary space. So other than that, if you use any space, extra space, only for the pure purpose of our logic, then it will come into the consideration. But this array list was declared for the output storing. Sole purpose is the return type initialization. So don't consider that. into the auxiliary space calculation. So other than that, if you see the second line, it is a for loop line. So it takes a big of n, obviously. So inside it, we use a simple variable Java which it takes big of n space. And this line also big of one execution, big of one, big of one, big of one. So final, the time will be what it is big of n, and the space will be big of 1. So if we compare our complexities, time and space, with the expected ones, the time is big of n, it is also big of n, satisfied, and the space is also big of 1. So here also big of 1. So using this index marking of in-place marking system of the given array only, in the case of some specific conditions met, like the 1 to n range of numbers only, and at most appear twice only. Like these conditions if appeared, then it is better to use this logic to find the duplicates in an array. So this is called index marking in place. So this was the dry run of our logic. This was a logic which we are going to use, or the concept, things we are going to use. Also we also executed it, the time and space complexity, and the actual code. The problem link is given in the description, so go and practice the problem. Thank you for watching.